So this question is about an experiment to investigate the kinetics of a reaction between iodine and propanol. Remember, iodine propanol reaction is a very common type of reaction, and it is zero order with respect to iodine. Like the rate of a reaction does not depend on the concentration of iodine. To obtain the order of the reaction with respect to iodine, the concentration of iodine in a reaction mixture was determined at various times. First 25 cm cube of 1 mole sulfuric acid, then 25 cm cube of 1 mole propanol in a beaker. Then we start a clock as 50 centimeter of 0. Iodine solution was added. The mixture, mix the reactant thoroughly. Then a spatula of measure of sodium hydrogen carbonate into a conical flask. What is the purpose of adding here sodium hydrogen carbonate? That is actually it's a quenching agent, like it reduces the rate of reaction or slow down, so it's quenched. After 3 minutes, the pipette 10 cm cube of a sample in a conical flask and we titrated with sodium thiosulfate. The experiment was repeat the step 3 after every 3 minutes to obtain 4 titrates. State why sulfuric acid and propanol concentration are both much larger than the iodine because look, why we use a propanol and sulfuric acid, because we want to determine the rate with respect to iodine, so that the other reactant should be in excess, so the rate does not affect by the change in concentration of the other reactant. That's why we use excess of or so the rate of a reaction, so concentration of sulfuric acid and propanol does not affect the rate, because high concentration means small change will not alter the rate. So the rate does not depend on, the rate should not alter by the concentration of sulfuric acid or propanol. That's why we use in excess. State why sodium hydrogen carbonate is used in step 3. As I mentioned, the purpose is to quench the reaction, like to slow down the reaction, we use the sodium hydrogen carbonate. It is used to quench. Name the indicator that would be used for titration step 4 and state the color change that would be seen at the end point. So look, we have iodine is there. This iodine is there, like when we added, this has iodine, and then we titrated with the sodium thiosulfate. When iodine react with thiosulfate, so iodine molecule will turn into iodide, and iodide is colorless. So in the presence of the starch, it will turn from blue-black to colorless. So name the indicator that would be used. So we use a starch as an indicator. And what is the color change? It will be from blue-black to colorless. Does not show any color. Next is the titration results are there. We have to plot a graph for time and titer. So plot the graph against the time, and the titer is there. So what will be the shape of the graph? As you can see, as the time progress, the amount of a titer which we, like after 3 minutes we need 16, then 15, 14, 13. So that is the volume of a titer we need, and the time axis. So the shape of the graph, with the passage of a time, the amount of a titer which we need, as you can see, it is decreasing. And it will be a linear graph, like on x-axis we'll have a time, on y-axis we have amount of titer. After 3 minutes we need more titer, after 6 minutes relatively less. And it's a linear relation, so what will the shape of the graph? It will be somewhat like this. I'm not sketching a graph, plotting a graph, you can, and the slope can give us the rate. So steeper the graph, and because the slope is constant, it means the rate of this graph will be, the rate of this reaction will be constant. State the volume of thiosulfate may be used for plotting a graph rather than the concentration of iodine. Suggest why the volume of thiosulfate may be used rather than the concentration. So what is the reason? Because here, like why we are using a volume of thiosulfate rather than the concentration of iodine. So you can see that iodine and thiosulfate are reacting with each other. Like if iodine is more in the solution, then we need more thiosulfate. So we can say that the amount of iodine in the solution, or the concentration of the iodine in the solution, how much iodine is there, or concentration of iodine in the solution, is proportional to the volume of thiosulfate. If we have more iodine in the solution, like a higher concentration of iodine, we need greater volume of a thiosulfate for a reaction. State the order of a reaction by referring your graph. So this is zero order reaction. Why it's a zero order reaction? Because you will mention it's a straight line which has a constant slope. So slope is constant, it means the rate is constant. And if the rate is constant, it means that the concentration or amount does not affect the speed of a reaction. So it is a zero order reaction. Further experiments were carried out to determine the order with respect to propanol and sulfuric acid. The graph of concentration of propanol in time, as you can see. The reaction is first order with respect to propanol. Determine the two half-life of this reaction and show you're working on the graph. So how we can work out the half-life? Half-life is the time taken by half of the concentration to become half of the original. So initially, like example, we have 0.2. So we'll find how much time it will take to become 0.1. That time will be the half-life. And same way, if we have 0.1, how much time it will take to turn to 0.05? That will be the second half-life. And you can just mention, you have to show on the graph and state the results on the this part. The graph of a rate of against the concentration of sulfuric acid is shown. So look, this is a straight line graph. What it shows that the rate is directly proportional to concentration. And if rate is directly proportional to concentration, it means it is a first order. Because if it was a second order reaction, then what will be the shape of the graph? This will be curved. If it's a zero order, then it will be a horizontal line. So it's a first order because the rate is directly proportional to concentration. And deduce the rate equation overall. So it's first order with respect to propanol, because if the half-life is constant when we do, so the first order with respect to propanol, and it is a first order with respect to acid, and it is zero order with respect to iodine. If you don't include iodine, that is fine. If you include iodine, that's also correct. So it won't make any difference. And I should mention K as well, because it's an equation. If it was an expression, then I will use the proportionality sign. But it's an equation, so it must have equal to and a constant value.